In this video, we're going to discuss the SAS triangle congruence theorem. SAS stands for side, angle, side, and it is one of the methods for proving that two triangles are congruent. So it says, if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. So let me show you how that works. This demonstration that we're looking at here is from GeoGebra, and the author is D. Gibson. So comparing this triangle here to this figure, what we're going to see is that we have side, angle, side copied here. AB is 7, A prime, B prime is 7, angle B is 97 degrees, B prime is 97 degrees, and BC is 6, B prime, C prime is 6. Even if I take this point here, A, and stretch it around, you'll see that the other figure moves to maintain that copy. So I'm just going to leave this right here. And again, so we have side, angle, side copied right here. Side, angle, side. So now what happens if I close this figure in here to make it a triangle? Let's see what happens. We notice that now the other sides and angles are also congruent. Angle A is 48 degrees. A prime is 48 degrees. Angle C is 41 degrees. C prime is 41 degrees, and side AC is 8, and A prime C prime is 8. So when we have that side angle side congruence, what we end up with is the other corresponding parts are also congruent, and that is how side angle side works. So let's take a look at these two triangles and see if they are congruent. So we see that side AB is 20 centimeters and ED is also 20 centimeters. So we know that AB equals ED, and they both equal 20 centimeters. We also see that side AC is 19 centimeters and side FD is 19 centimeters, or DF, whatever, it doesn't matter. So we know that AC is equal to DF, and they both equal 19 centimeters. So now, in order to have side, angle, side, we need the included angle to be congruent. So angle A is 43 degrees, and angle D is 45 degrees. That's the included angle. So they're not congruent. So the measure of angle A is not equal to the measure of angle D. So these two triangles are not congruent. So now what about these two triangles? Well, let's take a look. I see that side JL is 46 inches and side MP is also 46 inches. So JL is equal to MP, and they both equal 46 inches. And so how about JK? JK is 74 inches and MN is also 74 inches. So JK equals MN, and they equal 74 inches. And so the included angle is between those two sides. So angle J is 37 degrees and angle M is also 37 degrees. So the measure of angle J is equal to the measure of angle M, and they both equal 37 degrees. So these two triangles are congruent. So triangle JKL is congruent to triangle MNP. All right, now looking at this figure here, is triangle ABC congruent to triangle DBC? So let's take a look at our evidence. We see that side AB measures 30 millimeters and side DB also measures 30 millimeters. So AB is equal to DB, and they both equal 30 millimeters. We see that angle ABC is marked with one arc, and angle DBC is also marked with one arc. That means that they are congruent. So angle ABC is congruent to angle DBC. And so we have side, angle, and we need side. And obviously, we know that side BC is equal to itself. Side BC is part of both triangles. So BC equals BC, and we know that because of the reflexive property. Therefore, triangle ABC is congruent to triangle DBC because of the SAS triangle congruence theorem. So looking at these two examples here, let's use the concept of SAS to find the value for x that would make both triangles congruent. So we see here that side AC is 9 inches and side DF is 9 inches. We see that angle C is 30 degrees and angle F is 30 degrees. So in order to have SAS, we need side BC to be equal to side EF. So we can write this equation. 2x equals x plus 4. And then we just solve the equation for x. So I have variables on both sides, so I'm going to subtract x from both sides, and I find that x equals 4. So the value for x in this situation that would make both triangles congruent would be 4. Let's take a look at this second example. I see that side AC is 13.5 inches and DF is also 13.5 inches. Side BC is 12 inches and side EF is also 12 inches. So in order to have SAS, I need the included angles C and F to be congruent, to be equal to each other. So I can use that once again to write my equation. 4x equals 2x plus 14. And again, we solve for x, so I'm going to subtract 2x from both sides. And now I have 2x equals 14. And then I have to divide by 2. And my answer is 7. So the value x needs to have in order to make these two triangles congruent is 7. All right, now let's take a look at some proofs using SAS. It says here, given that side BD is the perpendicular bisector of side AC, prove that triangle BDA is congruent to triangle BDC. So let's look at our information and our diagram and see if we could come up with a plan for our SAS proof. So it tells us that BD is a perpendicular bisector of AC. Well, what does that mean? Well, that means that for one, it makes point D here a midpoint, which means that from A to D is the same distance as from C to D. So in other words, side AD is equal to side CD. So that's one of our sides. Now we need the angle, right? So since BD is perpendicular to AC, not only is this angle here 90 degrees, this angle here is also 90 degrees. So now we have side, angle, and what we need is side. Well, BD is part of both triangles, and obviously BD is equal to itself. So now we have our side, angle, side, and all we need to do is list our statement and reasons in the proof. So our first statement is that BD is the perpendicular bisector of AC, and that's given. Now that tells us two things. The first thing it tells us is that side AD is congruent to side CD. And our reason is definition of perpendicular bisector. The second thing that tells us is that angle BDA is congruent to angle BDC, and that's also definition of perpendicular bisector. Finally, we know that side BD is congruent to itself, and that's the reflexive property of congruence. So now we can conclude that triangle BDA is congruent to triangle BDC thanks to the SAS triangle congruence theorem. Taking a look at this next example here, it says, given side CD bisects side AE and side AE bisects side CD, prove that triangle ABC is congruent to triangle EBD. So now let's look at the diagram and come up with our plan. So if CD bisects AE and if AE bisects CD, that means this point here, B, is a midpoint for AE and it's also a midpoint for CD. So what does that tell us? Well, that tells us that AB is equal to EB. And that also tells us that CB is equal to DB. So we have our side and our side. What we need is the included angle, which would be angle ABC and angle DBE. And how do we know that they're congruent? Well, they're congruent because they are vertical. So our first piece of given information is that CD bisects AE. That tells us that AB is congruent to EB. And that's definition of bisector. Our next piece of given information is that AE bisects CD. That tells us that side CB is congruent to side DB. Once again, definition of bisector. And we know that angle ABC is congruent to angle DBC because vertical angles are congruent. Now we can prove that triangle ABC is congruent to triangle EBD because of the SAS Triangle Congruence Theorem. All right, I hope this lesson helped you to understand the SAS Triangle Congruence Theorem.